Now, no doubt you're all familiar with one of the world's greatest ever album covers. And this album cover clearly showed that if I shine a beam of white light through a triangular prism, the light will split and I will end up with a whole rainbow of colours. Now, obviously, I'm far too lazy to draw a rainbow, but 3 colours will do. And you could see that wonderful, wonderful spread of all the different colours that make up white light, all of those different parts of the visible part of the electromagnetic spectrum. What that album cover doesn't explain is that there's a whole range of invisible radiations on either side of the visible spectrum. And just in this range here, right next to red, very conveniently given how it's named, we have a region that we call infrared. Now, infrared radiation is really important. Infrared radiation, or IR, is one of the ways that heat can travel. So infrared radiation is heat traveling as radiation. The first part of this topic, this module, is all about heat traveling from one place to another. And infrared is amazing. Infrared is how heat energy gets from the sun to us. You'll see when we look at the other 2 ways that heat travels, they can't happen in the vacuum of space, but radiation, as infrared, can carry heat from the sun to Earth, which is thoroughly good news for all of us. So, what gives off radiation? Well, firstly, we need to know that everything, all objects, will emit infrared. Anything, as long as it's above the temperature of absolute zero, the coldest that it's possible to be, everything will emit some infrared. But obviously some things will emit more than others. So if I have as it's getting close to bonfire nights, if I have a sparkler, it will emit a lot more infrared than, let's say, someone's hand. Someone's hand will be emitting infrared. They're at roughly 37 degrees inside the body, and so they are emitting infrared, but nowhere near as much as this really hot object. So objects emit different amounts of infrared depending on their temperature. They also emit different amounts of infrared depending on what colour they are. If you imagine I have 2 surfaces, I have one that is really, really dark and really matte, so dull, not at all shiny, and I have another surface that's really, really light and really shiny, then you will find that this surface is a better emitter of infrared. Now that's really interesting because that means we can control how much infrared something emits, not just by what temperature it's at, but what we make it from. So if I want to make something that is going to stay warm, I don't want it to be a good emitter, so I would choose something light and shiny. Now the same goes actually in reverse. The same goes with what happens if I have a surface and infrared hits this surface. Well, there are 3 things that could happen. It could be transmitted. It could go through surface and out the other side. So there are some things that are transparent to infrared and the infrared will pass through them. It could be absorbed, and that would mean that the energy would get sucked into this surface. It would be trapped there. Now, what would that do to the surface? Well, it would increase its temperature because this is heat energy traveling. So that would make the surface hotter. Now, what objects are good at absorbing? Well, good absorbers are things that are dark and matte. The dull surfaces are really, really good at soaking in that infrared radiation. But there's a third thing that could happen. It could be reflected. It could bounce off. Now, that's also really useful because if I want something to stop infrared, then reflecting it would be a brilliant way to get rid of all of that energy. And the surfaces that are best at that are surfaces that are shiny and light. So something that's white coloured or something that's shiny like tinfoil is really good at reflecting infrared radiation away. So I have a lovely, lovely flask that's going to keep my coffee nice and warm. How do I stop energy from escaping as radiation? Well, I just put a very thin layer of something shiny and light. And what happens to the infrared radiation that my coffee tries to emit? Well, when it reaches that shiny surface, it ends up being reflected back into the drink. So I can use reflective surfaces to protect something that I want to keep hot, to keep that heat energy in. I could also use something black and matte if I really wanted something to be good at absorbing or emitting infrared radiation.